Hello and welcome to another episode of the How to Create VR tutorial series, where you learn by watching other VR, AR, and MR professionals create the magic. I'm Marshall Anschutz, an immersive content specialist focused on e-learning and training. I'm also the creator and the guy behind howtocreatevr.com. My guest creator today is Marshall Anschutz, a VR software and hardware creator with over 5 years of experience. Marshall has created hardware prototypes of the Samsung Gear 360 camera, as well as helped Samsung scale their early VR video platform, SamsungVR. Today, Marshall will be showing us how to set up a Unity project for using the Oculus Rift headset and controllers. But before we get started, I want to remind you to register at howtocreatevr.com. It's free, and registration gives you access to all of our live events, tutorials, practice assets, podcast interviews, videos, and more. Just visit howtocreatevr.com and click on the Register for Free button. Finally, if you want to attend our live events in virtual reality, join us inside Altspace VR. Just visit howtocreatevr.com/AllSpaceVR and subscribe to our channel. All right, Marshall, welcome back to the tutorial series.
Thanks for having me on again.
The reason I say welcome back is because you've completed for us the same tutorial, but you did it on the HTC Vive. So for those of you that are interested in also developing for the HTC Vive, you should definitely check that out. It's titled exactly like this one, except that it's HTC Vive versus Oculus Rift. So thank you for doing that.
You're welcome.
So I love interviewing my presenters before we get started on the tutorial. So I just wanted to ask you, why did you become a VR creator? What attracted you to VR?
Well, back when I started with virtual reality, the campaign had just kind of ended for the Oculus DK headsets. And so there was a lot of interest in the community, but nobody really knew even what virtual reality was. The landscape was really open and anything could be done. The sky was the limit. Back in the past, I've done streaming technology before it became popular. I've always been wanting to push the boundaries on the computer to build new, innovative things. So this was a chance to be able to start fresh and really make a mark on computing history.
How do you see the future of VR? I mean, if you had control over it.
I think that it's going to take a little bit longer than most people want, but it's eventually going to become almost as pervasive as a smartphone, but in a completely different way than a smartphone.
How's that?
The virtual reality and augmented reality ways of taking over your field of view, your vision, is going to be able to provide us an ability to have so much more knowledge. We've said before that it was at our fingertips. Now it's going to be at our retinas. So that information with the vision, the cameras, the other sensors is going to be able to just really augment our world for our day-to-day life and completely replace. My wife, we have 2 small kids, and they're constantly screaming and running around the house. And she put on my Oculus Go the other day and pulled up Netflix. And all of a sudden, I was a single parent because she was immersed in a movie and was able to just completely transport and take almost a mini vacation in there. So the easier this technology becomes, the more that ability to either escape reality or go to a different place and experience something or help people there is going to be able to be a reality.
Yeah, I agree with you 100%. Well, Marshall, I'll let you get started on this tutorial. If I have any questions, I'll jump right in.
Fantastic. Let's create a virtual reality project here in Unity 2018. If you have an earlier version of Unity 2017 or 5, you'll want to upgrade before trying these steps, as Unity has added a new XR-based actor system for virtual reality and augmented reality to really tie those together. So I'm using 2018.3, and we are going to create a new project. So we'll click up here in Unity Hub, a real easy way to manage your projects and launch everything. So we click New and can give our project a nice title here. I'm going to call mine Oculus Demo. And we're going to use the 3D project template. The VR lightweight render pipeline is still in preview, so I wouldn't recommend it right now. Some of the textures don't map with the controllers. It's a little bit easier to get started with just the regular 3D template. You can turn on analytics with Unity or disable those if you don't want them tracking your information, but it does give you a cool dashboard as well if you log into their system. We could add asset packages here, but I'm going to show you how to do it manually in case if you haven't added those already. I'm going to go ahead and click Create. And now after our project has finished installing all of its assets, copying things around, we're presented with the main Unity editor window, and we're able to go to the window menu and select the asset store which has been moved a little bit here in 2018.3. Once you get in the asset store, you can type in Oculus integration and search. Okay, and our integration plugin comes up here as the first asset usually. You will need to click download or upgrade in this magenta button if you haven't done that recently. They just came out with, as of this time, 1.31 or beyond. I think they're up to 34 now. The post 31 versions actually allow you to use a HTC Vive headset. So it's really important that you upgrade to get the latest features. After you click upgrade, then this button may turn into an import button or it may not. It's kind of a weird bug in the asset store. If it doesn't show up as an import button, go ahead and exit the asset store or possibly restart Unity, and you'll be back to this page again to click import. So I'm going to go ahead and click it, and it's going to start loading all of the different assets down from this package into the local project.
Quick question for you, Marshall. You said that this new version will allow you to use a Vive headset?
Yeah.
So the question that I wanted to get to was, does that mean that we really don't have to set it up as an HTC? You did another tutorial where you showed people how to set up the Unity for developing for HTC. Does that mean that if we use the Oculus integration, that'll take care of both? Or is there stuff missing here that the HTC has that's more specific to HTC?
Yeah, so that's a good question. The HTC tutorial is really a open VR tutorial. The HTC Vive is the most popular headset for the open VR, was one of the first ones that was out. But they've also taken some integrations there to do the Oculus in the Steam open VR concept. So technically that tutorial would have worked for a Oculus Rift if you run Steam VR. But this right here is for Unity, and the integration package for Oculus has some of the OpenVR stuff embedded in it. So now the camera rig that we'll install later will actually have the OpenVR stuff inside of it. So you're doing it from the perspective of an Oculus. You've got the Oculus touch controllers. They're going to map those buttons from Oculus to the Vive or to the OpenVR platform, whereas the other way around, they'll map from the OpenVR platform to the Rift's controller. So you may have some discrepancies based on which buttons you want to use. They all have different buttons, and it depends on if you want to have someone start up the Oculus store or the Steam store or some other method of installing. There's kind of two ways to get to your app. So if you want to start developing mainly for Oculus Rift, then you should be able to port it with almost no effort. If you want to make something that's compatible with specifics of maybe Vive's special trackers, the special features of that, it may be a little bit harder to do that starting with an Oculus project. But the Oculus integration gives you Oculus's avatars that integrate with Facebook. So there's kind of a trade-off of different features that each platform has natively, and they're trying to bring them to each other as competitors, but slightly friendly competitors.
Yeah, no, that makes a lot of sense. I think ultimately is all the features of the Oculus with this, you'll be able to use, or most of the features that are comparable between the Oculus and the HTC Vive, you'll be able to use with the HTC Vive. But if you have specific HTC Vive features that are not in the Oculus HMD, then that you have to do the other tutorial, which is specific to HTC Vive. So for example, in the future, eye tracking, right? Oculus doesn't have that, so that you wouldn't be able to do that. So it makes sense. Thanks for clarifying.
No problem. So we're going to import all of our assets from this. In a production app, you may choose only certain assets, but for this, we can just start and import everything. And this is copying the files from the plugin into our local assets folder of the project, so that whenever you modify something here, it doesn't modify the master assets that were downloaded from the asset store. Those assets are kind of permanent to be shared between all the different projects and should be able to upgrade your project without worrying about interfering with each other. So you don't have to worry about deleting something and messing up one of your other projects.
So while it's doing that, real quick question. So you download it into a central location and then you import it into your project. Now, if there's a new version that you update, it'll update the central location. Will it update your projects as well? Or do you even need to update your projects?
Great question. We need to update our project whenever we update from the asset store. So you go back to the asset store, search for it again, and click upgrade if you need to upgrade, or if you've already done that, just click the import button again, and it'll copy over anything in your project with those same path names. It's kind of a known issue with Unity that you can overwrite with different projects, different assets could have competing names, and there's some potential conflicts there. They are working on a new asset system that will take care of a little bit of that. But for now, we just cross our fingers and hope that nothing overwrites.
So is best practice with every new project you create is to, number one, check for the Oculus integration that it's the latest, and then import that?
Correct.
Okay, makes sense.
Mm-hmm. And watch their change logs. They do add really useful new features and bug fixes, things that will help make it work a lot better. So now that we've upgraded the plugin, it's going to ask us if we want to change to the latest version. The 1.34 is what I have. If you have a higher version, it should work the same way. We're going to say yes. It's going to install this as an actual plugin into the Unity editor and force us to restart. So we're going to restart Unity. It's going to bring in everything, and it should have a couple more menu options and things specific for the Oculus integration. We can see up here now, we have an Oculus menu. It gives us some specific tools for our platform. It can be used for the Rift. They also have the Vive, and coming out soon, the Quest. Those type of settings are also in here to control. Don't need the asset store anymore, but we do now need to modify our project settings here in Edit. We'll go to Project Settings, and in here we have our player controls. We can, of course, change the company, product name, all that stuff in here. And we're going to change our scripting runtime, make sure it's the .NET 4X equivalent, and that the API compatibility level is set to .NET 4X. That's very important for some of the code to compile properly. For your scripting backend, Mono is fine. It runs fast and compiles fast for development, but it's actually more featureful to use the IL2CPP. That is changing the intermediate language, the .NET code, actually compiles it down to machine code. So the compile times are a little bit longer, but it gives you a little bit more performance, which is really important for VR. So that would be the setting that you would change for production, a real app. For this example, it's not a big deal. We're going to now change our XR settings for mixed reality and enable virtual reality. You'll notice here it installs a few things for Oculus, and it actually has a couple settings that we could adjust. It's not really a need to change them right now. You can also configure the priority between OpenVR and Oculus, which one it will choose first. So now that we've configured those things, we can see our input settings. It's also given us a whole bunch of the Oculus for the legacy input system. You can use these if you want. There's also a little bit more advanced way that we'll go through later here in the tutorial. But now that we've set this up, we have the foundation for Unity to build an Oculus compatible application. In Unity, we build everything in the context of a scene. Let's build a sample one here to show off our skills. So first, we need to import some example assets. I have some already in our example project that's linked in the tutorial guide. If you open up that zip file, there's an examples folder. We have a rocket ship. It's got two different files, an FBX model of a rocket ship and a texture JPEG file. These were downloaded off of Sketchfab with a free license, so we can use them in the project. The easiest way to import these would be to just drag the rocket ship folder into our assets area, wherever it is that we want to store it. So we're just going to drag it right here, and we have a rocket ship. Let's take this and select the rocket ship model. The texture and materials need to be mapped together. It goes rocket ship, texture with a material in between. So first we have to select the materials tab on our inspector and extract the material. We can use the folder that it's in, and you'll see the texture shows up. Now we can drag this texture into the albedo channel, which is color, and it now has the color applied to this material. The rocket ship now can be remapped together. So we expand on-demand remap, search and remap, which should grab that texture and apply it. You can expand it out and see that there's the actual model, and then the material is applied here. So we're going to drag that into our project just to give us an example object here. You can move it around a little bit and place it. Let's also add a 3D plane that we're going to use as the ground. This one we also need a texture, or at least a material. So we're going to select material, call it ground, and grab just a simple green should work for the example. Now you can either drag this onto the plane, you can drag it here into the window, or you could drag it into the inspector if the plane is selected. Several different ways to configure that together. So now that we have a rocket ship, we can add another one, place these around in the scene so we have something pretty to look at, get our bearings. We want to show this in VR, but first to do that, we're going to have to delete our main camera. Just select it, press delete, and then open up Oculus, open up the VR folder, and go down to prefabs. Here you have several different options. One of them is this OVR camera rig. Drag it into our project, and now we have a fully functioning camera that works with our headset. We need to change our tracking origin type here in the inspector to floor level. And the floor level will allow the camera to use our foot position that we've set on the Oculus configuration in the Oculus dashboard on everyone's machine. So like I'm 6 foot tall, it says 6 foot is the difference between my eyes and the floor. If someone else is 5'5", then it's going to set that as the height of their eyes relative to the floor. So the system really allows you to feel natural, like you're not floating or sinking or on your knees or something. So we usually want to use floor level, unless if we have a scene that is maybe like a tiny model that you want to center around your head, a small close space that you don't need to see your feet, maybe a sitting type of scenario, something like that. But for most projects that are free roaming, you want to use floor level.
And where does it pick up your height? Is that something that we set up when we set up the Oculus Rift as a user?
Yeah, so here I'll bring up the Oculus controls just for your computer. You select your account, and then you're able to go into the device, configure, and setting up the sensors. It allows you to configure that.
Yeah, that makes sense.
Exactly. Now that we have the headset in here, we need to add our controllers. The controllers are under Avatar here in the Assets and Content, Prefabs, and there's two versions. There's a local and a remote avatar. These are the hands, the face, the body of a person, entity in virtual reality. The local avatar takes instructions locally from your headset and will display those. So by default, it's going to use the hands and show those, hands and controllers. The remote avatar will show from a system that maybe a multiplayer game or some other type of scenario where you're actually receiving network-based commands for that avatar. But you can use a local avatar even to show yourself as a third person, say a mirror or something like that. So now that we have the local avatar in our scene, we want to select Start with Controllers, which will actually place the controllers in your hands in the VR scene. Now that we have that selected, let's hit play and see if everything works. When you take your headset and you look at your controllers, mine may have turned off here, you can see that they match your hands. Right now I'm pressing the trigger button. You should see that change. It's not. The reason is I'm holding my headset. The Oculus goggles have a sensor in them that knows if you're putting them on. And so until you actually put the goggles on, there's a glitch here in Unity that won't let them work. I'm actually holding my finger over the infrared sensor. It's possible to put a piece of tape over that if you're developing and just want to use your headset as a kind of a remote control instead of putting it on. But it gives kind of a close approximation of what you're doing with your hand. that is matching mine really close. So now that we can see our scene in the goggles, we're going to be able to add some interactivity. Let's make something happen now when we pull the trigger on our controllers. First, you have to make sure that you're out of the viewing mode by stopping the play. It should not be blue, or anything that you do will probably be reverted in the editor when you stop the project, losing all of your work. The next thing we need to do to actually add the interactivity is to add a simple empty game controller into our project, make a blank game object, and then in our assets, we're going to create a C# script. I'm going to call this my game controller, and we'll be editing this in Visual Studio after we add it to our scene. Select the game object, and you just drag it over here to add this component into our project. When you double-click on the C# file, it will open Visual Studio, which we have over here, and it gives you a object that subclasses from monoBehavior, which is kind of the base class of all of the different Unity things that you do. So we don't need anything in our start scene, but we do need a public object called game object, or a type game object, which is the base class of everything that is in the hierarchy of Unity. This game object will call projectile, and we will actually be able to configure that from the Unity editor. On every update, this is called once per frame, as you see in the comment there, we are going to check and see if anything has happened with buttons. The OVR input is where we can retrieve buttons. And we're going to say OVR input dot button, which uses the default mapping of buttons. So I'm left-handed. My primary controller is going to be my left controller. If you're right-handed, your primary controller is going to be your right controller. So I'm going to say primary index trigger, which uses our index finger trigger of our primary dominant hand. And whenever it detects a down, that happens only for one frame update. So we have to check it here every frame update. We can now check and get a vector 3 position of get local controller position. And we're doing that of our remote control. Can do this.
And you made it vector 3 because XYZ, right?
Correct. So position is an XYZ. The next one that we're going to get is rotation. And we're going to use a quaternion of similar get local controller rotation of this same object here. And one of the fun things that you can do in Unity is instantiate, which will either clone an object in the hierarchy or create a new one from your assets. And we're going to say projectile, which we've defined up above. And we're going to set a position and the rotation, which you can see here are the 3 parameters that instantiate can take. That will now set the projectile that we create, this rocket ship, to show up at the same position and the same orientation as our hands in 3D space whenever we press the trigger button. So we're going to save this. I hit Control S. You can do it from the menu. And go back to our Unity editor, where you'll see now with your game object, it should update and you actually get a new parameter here called projectile. We're going to hit the little button there, select assets, and type in rocket. Find our rocket ship and link it. Now we should be able to preview our scene again. And when I grab my controller, press the trigger button here, you'll see a big rocket ship shows up. So I can add a whole bunch of those. They're really large, so let's go back and change our rocket ship model real quick. One thing with Unity is that everything is based on cloning or instantiating, so we can go to our model here, settings, and change it to, say, 0.2, so 1/5 of the original size. When we run the project, we have to apply, and you will see that the rocket ships on the ground, wherever those are, there they are, have gotten much smaller, as well as the ones that we launch here are much smaller as well. So you can see the rotation changes as I rotate the controller. And you can also see that, of course, the position, all of that stuff works. Now we haven't added any gravity or any of the other physics. That's probably for another tutorial. But you at least now can add objects, respond to the controller, and move around your scene in Unity. But playing in the Unity editor isn't enough. We probably need to make an actual executable out of this to share with our friends. So let's go to here, save our project. From File, Build Settings will allow us to configure everything about our build. We want to take our open scene here, this sample scene, add the open scene into our project to actually build. So this will be the first one, which makes it the primary. So it'll start up when you run your Unity scene. We can configure all of this for an actual build, the debug files, the Visual Studio solution, which we already have gotten in the editor there. And all those things are important later on down the road, making a real project. But just for a simple one, you can always hit build and run, or just build. It is important that you create a new folder so you don't stomp on stuff. So we can just say new folder. Let's call it build and select that folder. And it's going to compile our code. The IL2CPP that we looked at earlier would take a little bit longer to do this compiling, but the mono version is fairly fast. Okay, now our app just launched. After compiling, it gives us a window here to choose screen resolutions. You can disable this window, and also in the professional version of Unity, you can disable the intro VR startup screen. But for the free version, it does still work. You do just get Windows beforehand. Hit play. It's going to give us our little Unity startup logo, and then the scene will actually load. And once the headset comes online, it should perform just like the preview version, but as a standalone app, which of course looks much cooler in VR than on the screen, but you get the idea. So now we have found out how to create a fully functional VR executable. It works with the Oculus Rift, and as with the latest features, also could work with the Vive or other open VR projects if you submitted the app to the Steam store.
Marshall, thanks for participating in this tutorial today. I really appreciate it.
You're welcome.
If people want to get a hold of you, do you want to give a URL or a Twitter or contact, whatever you like?
Yeah, they can reach me on my website is unwritten.media. And there's also links there to follow us on Twitter. I tweet a lot. I also lurk on Facebook under the 360 and VR, several of those different groups.
Excellent. Well, thanks again, Marshall. And to the rest of you, I'm glad you're here with us. Just a quick reminder, if you want to access all of our live events, tutorials, practice assets, podcast interviews, videos, and more, register for free at howtocreatevr.com. Finally, if you want to attend our live events in virtual reality, join us inside Altspace VR. Just visit howtocreatevr.com/AltspaceVR and subscribe to our channel. So until the next episode, I'm Marcelo Lewin. Cheers, everyone.